Have you at any time reviewed whether we're genuinely alone in the universe or, on the other hand, assumed there's something different to our reality other than what we see? Imagine what is going on. Consider the possibility that the James Webb Telescope finally shows that we live inside a black hole. Join us as we figure out more about this world, spreading the news that will make you question everything you assumed you understood about the universe. So what exactly are black holes? They're similar to something out of a spine chiller. Sure, you may have seen them in science fiction films, but what's even more unsettling is that they're not just a fictitious concept. According to well-informed specialists, black holes in space are massive amounts of matter packed into an inconceivably tiny region. Imagine a star several times more gigantic than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been fascinated by black holes for quite a while. Initially, they studied objects in space so large and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. It is not easy to identify black holes as they emit no light. However, researchers have found ways to detect their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Furthermore, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce intense light emissions, and even affect the formation of new stars in some regions while suppressing it in others. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it implodes under its own gravitational force, forming a black hole. As these massive stars collapse, something surprising happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours. At times, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, it creates an incredible phenomenon that defies understanding. Researchers have been studying the size of these astronomical phenomena for a long time. Black holes come in two sizes, large and small. However, small is relative when it comes to black holes. Extremely large black holes, remnants of massive stars, can be as much as 10 million times the mass of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a tremendous number of black holes that could swallow anything in their way. Very large black holes exist at the extreme end of the spectrum. They are millions, if not billions of times more massive than the Sun. These reside at the centers of large galaxies, including our own Milky Way. They appear like a massive dead space pulling everything toward them. The prestigious physicist Stephen Hawking studied black holes throughout his life. His theories were well established, but some of his ideas proved challenging to confirm due to a lack of cutting-edge technology. Yet now there's hope on the horizon. The James Webb Space Telescope. A revolutionary instrument is changing everything. The James Webb Space Telescope, JWST, and it is here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It is an engineering marvel, a demonstration of human ingenuity. Sure, we've launched other space telescopes before, and they've done their job well. But this rare machine is on a level that is truly extraordinary. The JWST makes the Hubble Space Telescope, which has served us for so long, look like a basic tool in comparison. The cost of this cosmic wonder is an astounding $10 billion. Yes, you heard that right, an eye-watering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities, to bring this marvel to life. However, we shouldn't forget the risks that come with such a monumental undertaking. This isn't an endeavor for the faint of heart. The JWST is venturing into an unknown world, stretching the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made several groundbreaking achievements. The JWST has captured stunning images of distant galaxies revealing hidden secrets of the universe. It has already identified compounds called polycyclic aromatic hydrocarbons, PAHs, around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are found everywhere from distant galaxies to comets in our own solar system. Astrophysicist Ismael Garcia Bernard from Oxford University examined 3 intriguing galaxies, NGC 6502, NGC 731, and the Stephens Quintet, as well as NGC 749. These galaxies are millions of light-years away in the depths of space. What he found is truly chilling. In those central regions where black holes reign, he noticed an overflow of PAHs. Sounds interesting, right? But here's where it gets eerie. The radiation near these massive black holes changed the structure of the PAHs, transforming them into larger electrically neutral forms of themselves. The smaller electrically charged PAHs disappeared into nothingness, consumed by the very darkness itself. The oldest black hole in the universe. Not to be outdone, the JWST has also identified what may be the oldest black hole in the universe, a giant beast weighing in at a staggering 10 billion times the mass of the Sun. This eerie, foreboding discovery was made at the center of a young galaxy just 570 million years after the universe was formed. And guess what? Cosmologists believe there may be even older black holes hiding in the depths of space. This discovery has sent shockwaves through the scientific community. It suggests that black holes played a key role in shaping the early universe, influencing galaxy formation and the cosmic structures we see today. The future of space exploration. The James Webb Space Telescope is giving us a glimpse into the darkest corners of the universe. And what we're uncovering is truly awe-inspiring. With each new discovery, we inch closer to uncovering the dark and astonishing secrets of the cosmos. Who can say with certainty what other priceless cosmic surprises await us in the vastness of space? As we continue to push the boundaries of our understanding, the relationship between black holes and dark matter remains one of the most enthralling mysteries in modern astrophysics. Dark matter is an invisible and mysterious substance that makes up a significant portion of the universe's mass, yet it has eluded direct detection. Unlike ordinary matter, dark matter does not emit, absorb, or reflect light, making it almost impossible to observe. Scientists only infer its existence based on its gravitational influence on visible matter galaxies and cosmic structures. Some researchers have proposed an intriguing theory: what if primordial black holes formed shortly after the Big Bang could account for a portion or even the entirety of dark matter? If true, this hypothesis could provide a revolutionary pathway toward unlocking one of the universe's greatest secrets. By studying the earliest and most ancient black hole, scientists may find clues linking them to dark matter, potentially solving a riddle that has puzzled astrophysicists for decades. Thanks to its unparalleled infrared capabilities, the JWST may be able to detect primordial black holes hidden in the distant past. If these ancient cosmic giants can be identified, they could serve as a missing link in our quest to understand the true nature of dark matter. If black holes and dark matter are connected, then the universe may be filled with far more hidden cosmic phenomena than we ever imagined. Beyond black holes, the James Webb Space Telescope has another groundbreaking mission: the search for life beyond Earth. While the Hubble telescope has provided glimpses into exoplanets, the JWST takes it a step further, analyzing the atmospheres of these distant worlds with extraordinary precision. By observing how starlight interacts with a planet's atmosphere, scientists can determine whether key chemical signatures exist, such as water, oxygen, methane, and carbon dioxide, which could indicate habitability or even signs of life. One of the most promising aspects of the JWST's mission is its ability to study planets in the habitable zones of distant star systems. The habitable zone, often referred to as the Goldilocks zone, is the region where conditions may be just right for liquid water to exist, a crucial ingredient for life as we know it. Some researchers believe that certain exoplanets could have biosignatures, chemical traces that hint at the presence of biological activity. If the JWST detects an atmosphere rich in oxygen and methane, along with other organic compounds, it would be one of the most significant discoveries in human history, potential proof that we are not alone in the universe. While most searches for extraterrestrial life focus on rocky exoplanets, some scientists theorize that life may thrive in environments vastly different from Earth. Could organisms survive in the clouds of gas giants? Could subsurface oceans on icy moons like Europa or Enceladus harbor life? With its powerful instruments, the JWST could revolutionize our understanding of where life can exist, shattering preconceived notions about the requirements for habitability. This mind-bending concept has been explored by physicists for years. The basic idea is that black holes might not just be destructive cosmic voids, they could also be gateways to entirely new universes. Some theories suggest that when matter collapses into a black hole, it doesn't just disappear. Instead, the singularity at its core could spawn a new universe with its own unique laws of physics.